Hello everyone. In this video, we can learn about the Cauchy-Riemann equations in Cartesian equations. The statement is suppose that f of z is equals to u of x comma y plus I into v of x comma y is analytic at some point z. Then the first order four partial derivatives of u and v, that is ux, uy, vx, vy exist and it satisfy ux equals to vy and uy is equals to vx. Here a and b are known as the Cauchy-Riemann equations, or simply we can call it as the equations. First we can go to the proof. Analytic function. First we can look into the definition of analytic function. If f of z is equals to u of x comma y plus I into v of x comma y is analytic, is said to be analytic at some point z, then f dash of z exists and is unique in the neighborhood of z. Means if the function is differentiable, then we can call that function as analytic function. Here if we observe the statement, the given function is analytic, means the given function is derivative at some point z. So given, now we can come to actual proof. Given f of z is equals to u of x comma y plus I into v of x comma y is analytic at z, implies the function is differentiable, means f dash of z is equals to limit delta z tends to 0 f of z plus delta z minus f of z by delta z exists and is unique. So now we can consider f of z, that is the f of z is given as u of x plus iy plus I into v of xy. Next is consider the f of z plus delta z, means x changes to delta x plus delta x and y changes to y plus delta y. Then we will get u of x plus delta x, y plus delta y plus I times v of x plus delta x, comma y plus delta y. So using f of z plus delta z and f of z, the value of f dash of z becomes. So what is f dash of z? So f dash of z is equals to limit delta z approaches to 0, f of z plus delta z, this f of z plus delta z can be replaced by this value. We will get u of x plus delta x, comma, y plus delta y plus I times v of x plus delta x, comma, y plus delta y minus u of x comma y plus I times v of x comma y whole divided by delta z. Take it as some equation number 1. Now here x plus delta x is there. If we consider the points, so one point is the x comma y, and this point is x plus delta x comma y plus delta y. So this point might be, we can approach from one point to other point either parallel to x-axis or parallel to y-axis. So there are two ways. So either we can approach the point x plus delta x, y plus delta y to xy either parallel to x-axis or parallel to y-axis. So now delta, we know that z is equals to x plus iy, and delta z is delta x plus I delta y. So we can discuss in two cases. First case, delta z approaches to 0 parallel to x-axis or approaches through the real axis. So in this case, delta y is equals to 0. So delta z becomes only delta x. And the further condition, delta z approaches to 0 implies delta x approaches to 0. So we can replace delta z as approaches to 0 as delta x approaches to 0, and simply delta z as delta x, and substitute delta y as 0. So using all these substitutions, equation 1 takes the form f dash of z is equals to limit delta x approaches to 0. So if you observe, the value of delta y goes to 0, and here also delta y goes to 0. So then the equation will simplify to u of x plus delta x comma y minus u of, sorry, plus I times v of x plus delta x comma y minus u of x comma y minus I into v of x comma y divided by delta x. So now group the u terms together and v terms together. We'll get limit delta x approaches to 0, u of x plus delta x comma y minus u of x comma y divided by delta x. So next is, if we are going to group the v terms, the I is multiplied to the both the terms, so we can take I outside, then the equation becomes I times limit delta x approaches to 0 v of x plus delta x comma y minus v of x comma y divided by delta x. Here we remember, we can make a note that from the first principle, the definition of dou u by dou x, or the other notation is ux is limit delta x approaches to 0. There is a change in x, so u of x plus delta x comma y minus u of x comma y divided by delta x. With this notation, the first equation, the first term will is the partial derivative of u with respect to x, so we can write ux, and the second term, this term is the plus I times we can write it as partial differentiation of v with respect to x. So this is the f dash of z. Consider it as equation number 2. So we got f dash of z as ux plus ivx when the delta z approaches to 0 parallel to x-axis. Now consider the case 2. Delta z approaches to 0 parallel to y-axis. In this case, delta x equal to 0. So delta z is the delta x plus I times delta y. So as delta x equal to 0, we'll get delta z is equals to I delta y. So from the limiting value, delta z approaches to 0 means I into delta y equal to 0. Further, we'll get delta y approaches to 0, means we can replace delta z approaches to 0 as delta y approaches to 0. So on substituting back, here we will substitute delta x as 0, and here also delta x as 0. We will get the equation 1 takes the form. So therefore, equation 1 takes the form f dash of z is equals to limit delta z approaches to 0 can be replaced as delta y equal to 0 u of x comma y plus delta y plus I times v of x comma y plus delta y minus u of x comma y minus I times v of x comma y whole divided by I delta y. So now 1 by I, collect the u terms together, we'll get limit delta y approaches to 0. So u of x comma y plus delta y minus u of x comma y whole divided by delta y plus along with v I is there, we can take I common. We can write delta y approaches to 0 v of x comma y plus delta y minus v of x comma y divided by delta y. So again, here also in the last equation, by using the definition of partial derivatives, we can write this first term as vx, sorry, we can write it as uy and the second term as vy. So with this denotation, we can write the last equation as f dash of z is equals to 1 by I uy plus I times vy. So 1 by I into vy plus I and I cancel with vy. So you can write 1 by I as multiply by I divide by I. The denominator is I by I square. I square value is minus 1. So we can write it as minus I uy plus vy. So this is the f dash of z. Take it as equation number 3. We can go back to the equation 2. Equation 2 is also f dash of z, that is ux plus ivx. Now we can substitute that in the equation 4. Sorry, from equation 2 we'll get ux plus I into vx is equals to minus I uy plus vy. So on comparing the two complex numbers, the real part must be equal. So ux is equals to vy and imaginary parts must be equal. So that is uy is equals to minus vx. So these two are known as Cauchy-Riemann equation. So hence approved. So any given function f of z is said to be analytic if the given function must satisfy the Cauchy-Riemann equations.